In this video, we're going to go over flow maps. We're going to go over what specifically are flow maps, how we can author flow maps, as well as what are flow maps in comparison to vector maps. We're also going to go inside of different programs such as Photoshop, Substance Designer, and Substance Painter to author flow maps. And then we are going to go into Unreal Engine and take these authored maps and generate a lava flow shader. So with that being said, let's get started. So what exactly are flow maps? Now, flow maps are very similar to things like vector maps. They are a little different in the fact that what flow maps do is they define very specific channels of movement, things like rivers, lava flows, smoke trails, anything that's not just general random omnidirectional movements. They're also very different compared to Panner node movements. Panner node movements are just very singular direction movements, and those are usually controlled by the UV coordinates of the material. So flow maps will allow you to actually create multiple various directional movements. Seeing here from this example, we have one that's just kind of nebulous noise. And then we have this one right here that has very specific channels of flow and movement around inside of the texture itself. So first off, they look very, very different. Now, going into what vector maps are and what the term vectors are is vectors essentially are data. The data in this case are going to be represented by color, and this color data is essentially going to are going to be represented for things like movement, speed, and direction for how we want these textures to actually move and distort the material that we want. And how vector maps work is they're very similar to things like normal maps or even UV coordinates, in that the normal maps and UV coordinates use the red and green channels to represent two different spaces of movement. That being that for the red channel, for both of them, they're going to represent the U or X for their corresponding values, or essentially the horizontal movement. So think almost like a coordinate graph. It's going to be moving from left to right, horizontal. And then the green is going to represent the V or Y or vertical movement on this coordinate graph. Now, depending on the render that you use, and I say render and not game engine because different 3D renderers actually use different types of maps because they're based on different architectures. So what we're going to say for this one is that there is OpenGL and DirectX. Those are the two that you're going to work with. But for us, since we're using Unreal Engine, we're going to use DirectX because that's the format that it takes. And what the difference between these two is, and as you can see by the example, they look very much the same. They have the same exact amount of details. They look almost exactly, but the colors are a little different. And the colors are different in one aspect, and that is the green channel. If you're using an OpenGL, you're going to have a gradient because, when you look at things like normal maps and, coordinate gradients, they're just a simple black to white gradient that goes in a singular direction. For the green channel, it's a gradient that goes up and down, essentially vertical. And for OpenGL, it's going to start off with black at the bottom, and then it's going to move up to white at the top. That's why you can see it's very light up here and very dark down here. Now, it's the opposite for DirectX. It's dark up here and white down here because it's going to be a black gradient that starts here and it's going to move all the way to white down here. This is very notable because if you use the wrong format, like say if you use OpenGL instead of DirectX, not only for normal maps, but for flow maps, they're going to invert the values and they're going to invert the look and appearance of the effect that we're going for. So we do not want that. And here's like another little quick visual thing, because we also need to understand how the directions look kind of on a coordinate graph. So for OpenGL, the origin 0, 0, essentially no movement where everything starts, is at the bottom left, and it's going to move to the top right. That's how this, 0 to 1, 0 to 1. That's how it's going to be for OpenGL. But for us with DirectX, it's going to be here at the top left, and it's going to move down to the bottom right. So just kind of quick little visual to note on how all that kind of works. And here's another quick little kind of breakdown. You'll see this right here. This is a UV coordinate. And this UV coordinate is supposed to define from where the origin starts, which is right here. And that origin, as you move to the right, is going to get to red. And that's showing that it's going to be this right here, this little gradient that goes from black to white. And then the same for green. See, it's black right here. It's going to move down to green right here, just like this guy. And then when we look at the, where they both meet, it goes from black to not green and not red, but yellow, because it is white in both the red and green channel. So that's why we have this yellow right here. So we need to make sure we note that, because these colors all are going to make sense, because they're going to be used for the directions that we're going to be painting inside of a flow map. And this little graphic here, even though it's an OpenGL example, is essentially going to be what we're going to be using. So the colors that we talked about, black, red, green, and yellow, they're all right here in the corners. But one color we have not talked about is this one right here. This color, which is kind of like mustardish yellow, but very dark, is the color of 0.5 in red and 0.5 in green. Now, this is necessary because what this shows is, and that's why this is in the center, is this shows there's no movement. It doesn't know to go up, down, left, right, or even diagonally. This color is essentially going to be a background of sorts. So if we go all the way back to the original, you see how this, off yellow colors right here? This means that there's no movement in the flow map here, but there is movement by all these other different color changes. And these different color changes actually mean something. What they mean is whatever color we use, it's going to show, hey, go this direction or go that direction, depending on the color that's being authored. And the thing to note about all this stuff is, at least for OpenGL, is it's going to be flipped for DirectX. So the green, lime green, and yellow is actually going to be at the bottom, and then all these dark red colors are going to be here at the top. These guys are going to be exactly the same because they don't change anything. Because remember, the only thing that's inverted between OpenGL and DirectX is the green channel. So only the top-down stuff is going to be flipped. But with this kind of basic understanding aside, let's hop into Photoshop and actually take this information and actually author a flow map to use. Okay, now we're inside of Photoshop, and I have already added in my base texture that I'm going to be using. To start off with the flow map, you're going to need to use this UV coordinate gradient here, because this is going to be where we're going to use to start the basis of stuff. Now, as you can see, I have it at a 1024 texture resolution. You essentially don't need to have a very high resolution image for this. Flow maps are great when they're blurry and soft, because you don't, this is supposed to be natural movement. There's not that many harsh like gradients, for things like water flows or lavas and things like that. So you don't want like an abrupt change or a sharp change. So having something be soft is, again, totally fine. So having this be low resolution is good because it also cuts back on the necessary textures for VRAM and stuff. So having something like this be smaller is perfect. Now, again, just so that you guys are aware, this is a DirectX based image, and if you're wanting to see if it works or not, just go to the green channel here and you can see black to white. And if for whatever reason, if you need to change this somehow because something was wrong or you grabbed the wrong texture, if you just do Control-I, it causes a grayscale conversion to invert, and this will make it a OpenGL. But again, we need DirectX, so we're gonna hop back into this. And how we're going to start now for authoring is, first let me rename this to be my base, and we're going to be working non-destructively. And what that means essentially is that I'm just going to be making more duplicates and not just deleting things outright. I want to be able to kind of look back at all the different pieces of this stuff so that I don't actually lose anything. So I'm going to quickly duplicate this. And the first thing we're going to do is we're going to use the smudge tool. This is how I'm going to actually shape a flow map. Now, how it all works is you don't have to start anywhere here. You can just choose whatever you want. You can do like a circle like this. And you can do this a couple times. The more circling you do, the more intense the final product will end up being. So if you circle this a bunch of times, you're gonna have a very strong and intense swirl. So it's up to you on how you want to do that. You can do something like that. You can do, a figure eight if you want to. It's however you want. You can even do things, like I had mentioned, where you just do like a little shape or something like that. It's, like I said, up to you on how you want to approach something like this. So now that we have something like this, let's just quickly rename this to my smudge. And again, we're going to work non-destructively, so I'm going to start doing duplicates. So if I grab this, the first thing we want to do is, and how to actually author these flow maps is going to be, is we need to kind of separate these values a little bit. We need to separate the movements that go up from the movements that go down, because the colors, the reds and greens and stuff, are going to be actually separated in there. And then we're going to be able to take those colors and then recombine them to create a flow map. So we're going to be using two different types of blend modes, blend modes. So things like we're going to use a lot of difference, but we're mostly going to be using darken and lighten to grab the lightest parts and darkest parts of these smudges that you see here. So let's first start off with darken. So by grabbing the smudge texture and changing the mode to darken, we'll use this. And then I'm going to take this darken version, and I'm going to, of course, just duplicate them real quickly. And for this one, I'm going to grab a lighten, and I'm going to duplicate him as well, and then just bring him back to normal. So from here, I can take these guys and I can even just duplicate them outright, just like I did before, and just, merge these layers together so I can have this. So that was my darken. And then here is my lighten. So grab him, merge the layers, and I'll just delete these old ones because I don't need them anymore. So again, this is my lighten, and then here's my darken. Actually, no, I think I might have accidentally deleted the wrong one. So let's just, start off from scratch again. And just start off with the smudge. So I'm going to grab my darken again, grab these two, merge the layers, and call this one darken. And I'm going to grab this one and change him to lighten, delete him, and merge these layers. And that'll be my lighten. And I'll bring him back to normal and hide him. So now that we have a darkened version and a lightened version, so we have the two, you can see they're different. Now what we need to do is we need to now extract the parts that we've changed from the gradient, because this is our kind of test area. Nothing's happened here, nothing's changed here. Now we want to isolate the smudges themselves by themselves. And in order to do that, we need to go to the lighten or darken, and we're going to use difference. And what difference does is it cuts out any change that was made from the original. This is the original, this is the difference. So I'll grab these guys, merge these ones, and call this one my lighten difference. And I'll hide him. Now I'm going to grab my darken, grab the base, and do the same thing. And I'll call this one my darken difference. And I'll merge these layers. So now I have my lighten and my darken. I can hide them. And now I have my lighten difference and my darken difference. Now we need to actually not use the gradient anymore, and we need to actually use another base. And this base is something we've already talked about. Like I had mentioned, when we do use flow maps, we need to use a flat color that represents no movement. And if we look, if you scrub back over to where we talked about that little kind of, where all the arrows are pointing in different directions, the middle point was this color right here, this kind of mustard yellow. It is 127 and 127 in the red and green channels, and this represents 0.5. So essentially the middle of a coordinate graph of the positive square space. So using this, if I grab a fill layer, I'll just fill him up. And again, this is my yellow. You don't see anything, but we're going to use this. Now I'm going to take these guys and I'm going to combine them on top of this, mustard yellow. And doing so, here actually, I'll just duplicate these guys so that I can move them down below. And how it's going to work is for lighten, we're going to change the blend mode now to add, so linear dodge. And then for the darken, we're going to subtract. And now, as you can see, it looks like a flow map, because what it's doing is that it's adding, which what add does is, again, is it takes anything that's not black or above black. So anything that's like 0.01 to 1 will be added on top. And then darken will take the subtractions. So if there is anything that's in the black, it doesn't do anything. But if there's anything that's above the value of 0 in black, it starts to subtract or cut away from it, making it darker. So these two combined with this will cut and add together to make this flow map again, but with this, mid value. So I'll select them, merge the layers, and that right there is my flow map. And if you want to just kind of quickly look at the original smudge, as you can see, looking pretty good. All the colors typically match. They look pretty well. They're going to be a little different because now instead of it being a base of, a gradient, it's now a base of a flat solid color. But this right here is the flow map that we're going to use. So we can quickly save this and then we can just move on from there. But I've also done a couple different methods of authoring inside of programs like Substance Designer and Substance Painter. So we're going to quickly hop into those right now. So now we're inside of Substance Painter. And as you can see, I just have the first start of this thing that I have right here. It's that kind of flat 50% yellow color. I've also, again, set the document size to about 1024. Again, we don't need to have a very high resolution flow map. Again, it can be blurry and soft, so lower the better. But what I have in here is I actually was able to take everything that we've actually done to make a flow map inside of Photoshop with all the different blend layers and stuff. And I was able to properly take all that and actually create a layer stack that actually does exactly everything you would need. But instead of me having to do it every single time as I do a paint, I, paint once here inside of this one layer. And that allows me now to just paint directly and see what the flow map looks like without having to paint first and then do all the different blending layers. This is going to be something that I'm going to be putting up on my Gumroad and ArtStation as well. Just, nice, simple little tool. Again, you don't have to use this. You can even just use Photoshop just to handle all this stuff too. But if you're more familiar with Painter, then this also does exactly the same. So inside of Painter, I'm going to go here and into the layer stack and find the one that I have that's colored yellow, and that's my smudge layer. So just like how we used smudge to paint our flow map, we're going to do the same thing here inside of Painter. So I'll grab this layer that says paint flow map smudge here. And first, you want to make sure you don't use the brush that's up here on the left, because if you just use a brush, it's just going to paint white because it's just going to paint color. We don't need a paintbrush. We need the smudge tool. So if we go just a bit further down and find the little finger hand tool right here, that's smudge. And let me just adjust my brush a little bit. And if I just start to paint, as you can see, as I'm painting, I can actually see the flow map generating without me needing to, again, do all those layers and merges and combines and stuff like that. I have the actual tool working as it is. So this is the big fundamental thing that if you want to create your own flow maps here inside of Substance Painter, you totally can. You can even take in like other little maps on top to help with like as a stencil, or even just like as a way to kind of trace over. Like if you took a screenshot of your scene from above and you want to kind of shape the flow of the river that you have, where there's like rocks and then there's the water, you can use that as a way to kind of help guide your flow map brush. But with that being said, we were able to actually, paint something here inside of Substance Painter. Let me quickly hop into Designer and kind of show you something similar to this. So now that I'm inside of Substance Designer, as you can see, I have made myself a nice little flow map generator as well, though this one's not going to be as robust as the Substance Painter one is. It's just going to be a very simple conversion filter. So essentially all it's going to take is one single texture input and then do the calculations and conversions to generate a standard flow map. And how it's going to look is like this. So I just have this single little node right here. I have at the very least just a smudge map. So this is just, again, the texture gradient with a simple little smudge right here. Honestly, I probably could have done maybe even doing like a texture coordinates, like making a texture coordinate node and then using probably one of the splines inside of Designer. And then from there, taking one of the splines, moving them around, and that generates a nice simple little movement. But again, the problem with using splines is that, you have so many opportunities to generate something, but it's not as, say, robust as using like a simple little brush spline. So from there, you can just generate your own, going to things like Photoshop and just quickly smudging something around like this, and then bring it here inside of Substance Designer, do the calculations, and boom. As you can see, we got ourselves a nice, really easy to use flow map. So this is our third way of generating inside of a flow map. Like I probably should have mentioned earlier, there are other methods and other tools to use flow maps for. And if you have, come from looking at the work and tutorials that I've done on CGMA about flow maps, one of the reasons why I did this was because I wanted to show a different way that didn't use a tool that could very, very easily just be, brought offline, because the two tools are found on someone else's website. They're websites that are hosted, and, we don't know if, say, one of those things goes down, how do you generate your own flow map from there? These are different ways you can actually use to generate flow maps without the need for something like that. Photoshop's not going away, Painter's not going away, and Designer's not going away. These are all stuff that if you take the time to, you can generate your own flow map generator, or you can even generate your own smart material to generate things like that. All the tools are all here so far. But now that we've done our authoring, let's take the maps that we have painted and bring them inside of from Substance Designer and stuff into Unreal Engine now. So before we hop into Unreal Engine, I just wanted to kind of quickly go over kind of the order of operations on how we're going to approach authoring this lava flow shader. So here's like a quick little kind of video demonstrating what we're going to go over. So first, we're going to start off with using a standard UV panner, to pan in a single direction. That's going to be the big movement. Then we're going to use a flow map that's going to help distort along that. And then what we're going to do is we're going to take the distortions, apply a distance field. There's going to be two, actually. So one distance field is going to be used to help add more secondary and tertiary movements to the lava flow. And then we're going to use a distance field to actually mask around the lava area, which in this case, we're using a checkerboard texture as like our little debug. And then I'm going to use the actual distance field surface to mask out a kind of skirt around where the intersection of the lava rock is from the shoreline, so that we can actually create a almost cool, cold, or just kind of transitional material to make sure that things kind of blend a lot more naturally, probably. So from there, we'll just turn on the lava, and you can see with all the distortions and panning and movements that they shape around everything. This is exactly what we're going to try and do as we hop into Unreal Engine. And here we are inside of Unreal. So I have my little test scene right here. I have a couple different materials that I'm actually going to be using for my quick little scene that I have that I just quickly demoed. We're going to be creating something similar to this material right here. So we have a single panning UV coordinates. We have distortions happening based off of flow maps, as well as using things like vector maps, distance field gradients to help add more secondary and tertiary movements on top of, and then again using distance field to help mask around these objects. You can see when I move this guy around that the distance field flows and creates a mask no matter where he goes, but also as I move him around, and I move even say these guys around, as I move them away, you'll see that they actually warp and distort a little bit differently as I move them around too. So we want something like that to help with making a nice natural flow map. So with that being said, let's kind of quickly demonstrate what's going to happen. So flow maps aren't just like those maps that we're just kind of quickly authoring. We're using these flow maps to mess with the UV coordinates. So the UV coordinates, as you can see right here for this checkerboard, start off like this. And then depending on the type of, say, at first vector map, you'll see that we have a little distortion like this. So this distortion has this little wobbling, and that's just general random noise everywhere. That's because it's just using a standard vector map. Here is actually using a vector map that is sphere shaped. So it's creating that kind of bulbing out like look of appearance for our material. This is exactly what we want to try and go towards. And then as you see here, I actually have a flow map that actually is flowing a channel. So you can see that it's moving in this single direction. And there's other little things warping on top. If I move these guys around, you'll see that they actually are affecting the material. That's that distance field gradient that I'm talking about. It's going to be a lot more noticeable like this because I'm using a checkerboard. A black and white checkerboard is going to be a lot easier to notice this stuff versus, say, if I were to use my lava material. And these guys have like a sphere of influence. Even if they're not here, you can see that they're actually affecting around them. That's what's cool about distance fields is it doesn't have to be even intersecting. It could just be in the area of effect. So all this is to say that we're going to be using this to help generate a nice natural flow map. So let's get started over here by creating a new material that we're going to use in this demo. So let's quickly go to my content drawer. Let's go in here and let's make a new material. mm_demo_flowmap. And I'm going to right click and create an instance. So as I start to make different parameters that I can actually use to edit, I'll just have them there so that I can actually just quickly see what's going on. So let's hop into the material here. Let me also just make sure that I hit save real quickly. And let's open this guy up just a little bit. And let's grab our first texture that we're going to use. So again, we're using a checkerboard just to start off with. As I can see, when I hit save on here, you'll see the checkerboard is right here. So let's get started with the first basic bit of movement. And that's going to be our panning node. The panning node is going to be the first big general movement we're going to use. So we're going to quickly just get that out of the way. So let's right click and grab a panner node. Again, what a panner node does is it takes a UV coordinate and it takes the UV coordinate information, pushes it through here. It uses a time node. This allows you to actually apply time and like relative time values to start animation. So plug that in. And then speed is going to be kind of how fast and in what direction the panning is going to be. Now, I could just quickly go in here and grab a bunch of scalars like this to mess around with things. Like I'll say, hey, I'll go in here, change the speed of this, change the speed of that. Because each one of these guys I can actually plug in. First off, these two would probably be for my speed. And then these two I would actually use for my texture coordinate. Because just like if you've looked at the other videos and things about like master materials and how to tile things, especially if you look back at my shader math, if you use a multiply node with a value with a texture coordinate, the texture coordinate can be multiplied or tiled more or less using one of these values. And in order to use two values, because right now I only just have one slot, you can use another node called a append node. And what append does is it takes two values and it doesn't necessarily combine. Get append. It doesn't combine them together. Like if I plug this one and this one here, they're not going to combine. They're just going to be put together as a pair, and that pair can now be slotted together in one slot instead of them being like only one taking one slot. You can actually pair both together. And what this will allow me to do is inside a UV coordinate, there's two values. There's two vectors, a U vector and a V vector. Now, because this is the first one and this is the second one, this will be my U vector and this will be my V vector. So if I do this, if I times this, say, by 2, it will multiply in the coordinates on the U vector so that when I plug this guy in, he's going to actually look different because he's now tiling 2 times in the U vector, the horizontal vector. If I change this guy to 3, then he's going to tile 3 times in the V vector. Now, the same can be said for if I do an append vector like this and plug them in like so. Now, how these guys work is they're very similar to the offset effect. So offset means that if it's 0, it doesn't move. But if you choose to set this to be whatever value, like say 1, 2, 3, or 4, it will start to move. So if I hit save, watch what happens. So you can see that he's moving in the, well, in this case, it's the X direction, but it's actually moving this way. If I probably rotate him like so, this makes a lot more sense. So watch, if I now set him this way and I set him to 1 here, you'll see that now he's going to move in the other direction. Like that. Perfect. So as you can see, he's flowing in the exact direction we want it to be. And if we were to look at this, just so we can see, that is our top left corner and that's our bottom right corner. If we remember all the way back to how UV coordinates work inside of Unreal Engine, they're going to start at the top left. So with this being 1, this is 0, that's 1. So if I set this guy right here to -1, he's going to go in the opposite direction, like so. So that's gonna how we know how we're gonna set this stuff up. So if I set him to be like 0.1, he's gonna move slowly, but he's gonna at least move coming towards us like this, or even say 0.2. So this is the start of our animations. Now I want to turn all these guys into parameters. That way I can edit them on the fly without needing to keep hitting save over and over again. But I don't want to use 4 different scalar values because this is just kind of not necessary. Because also I'll have 4 completely separate slots that take up so much space in the UI. So I'm not going to use that. And actually, let me just double click this so that we can have the instance right here. So what I'm going to do is I'm going to grab this. You'll see no parameters here. If I go in here now, if I delete these guys, go up. And if I go in here, actually, I just hit 4. I'm going to use a vector 4. So a vector 4 will give me 4 color channels to use: red, green, blue, and alpha. Now think about this: 1, 2, 3, 4. 4 different vectors. So if I grab the red here, the green here, the blue here, and the alpha here, boom, they all work. So let me convert this guy into a parameter and call this one my UV adjustment. And what's cool is if you're ever curious, like, hey, how do I know which one of these guys does which? Like if you say it's been a bit, you haven't opened up the scene in a little while, you need a little easy organization. If you go down here to this parameter, you can actually change the name of these guys. So you say, this is my U tiling, my V tiling. I'll call this my U offset because it's still an offset effect. It's still moving. So U offset and V offset. So that's what's really cool about this. I can actually know what's going on here. So let me also change the defaults for the U and V tiling so they can tile at least once. and I'll just hit save. And then boom, here's my little parameter. If I open him up, you can see as I move this, he's going to tile more or less, depending on however I want him to be. And if I want to, I'll just start to use this guy. Now it's going to be a little weird to see because how it kind of works is it's not the best like in the preview menu here. You can see it's like not really helping with the animation. So we're not going to look at the preview here. We're going to see the preview here. So if I do like 0.2, he's moving a little bit faster. But if I set this guy to at least like 2 and 2, I think we got enough information to generally work with. So this is part 1 of the animations. You know, some people, this is all they need. They need a simple little animation, and you know, that could work. You know, some people might actually be able to author like a curvy mesh that actually has like a straight UV tile, you know, of like coordinates and stuff. Like when you unwrap this mesh, you can have it be completely straight so that the pan actually does flow like in a river shape, but that's a lot to do. So we're going to actually still keep going with this. Again, we're going to combine all this stuff together. So this will be my first part. I'll just call this one my panner. And let's start off with the flow map part, because that's going to be where we're going to handle this stuff. So we're going to grab my flow map. So I'm going to grab this little one right here, and we're going to grab this guy right here. Now, you probably were curious when we authored the flow maps and the vector maps and stuff, how do, you know, when we bring this in, how do we set this up already? Like, how do we know what settings to turn this guy on to? So if I quickly go into this guy, all you need to know is, first off, he has to be linearized. You know, if we go back to the whole shader math stuff, if it's a data map, a map that represents data and not necessarily about the color itself, because the colors themselves represent data. And again, going back to this, vectors are data. The colors represent vectors. So this guy has to be linearized. So no matter what, he has to be. It's going to come down to the compression settings. And there's 3 that you could use. Vector displacement is the one I use by standard. It gives the least amount of artifacting with the distortion. Then there's normal map. And then there's, of course, using defaults. Now, defaults will give you probably the most like artifacting, so do not use that. Normal maps work very similar in Unreal Engine, where in that they basically handle most of the compressions on the red and green channels, but don't really mess with the blue channel as much. Because for the most part, most of the normal maps typically use a lot of green and red data versus blue data. So you can use a normal map too, that's another one. But I just generally have and seen from my little tests that vector displacement maps work the most, that have like the best quality in a sense. At least when I say quality, I mean the least amount of artifacting. So when you bring these guys in, set them to a vector displacement map, and then make sure that they're linearized, and you should be all good to go. And that goes for both vector maps and flow maps. So I have my 2 right here. So we're going to use this guy, and the first thing you want to do with a flow map is you want to find a way to separate out the red and green channels, because those are where we're going to actually see the most like change in things. So if I quickly go into here, say if I grab the RGB channel, if I grab a component mask, and I'll grab 2 of them. One can be, actually, I probably not the red, green, and blue channels, but at least grab the red and green channels. So this will allow me to actually use the red and green channels properly. So we'll grab this guy, and what I'm going to essentially do is I'll take him, and then I have to kind of convert his data a little bit, because we can't just use the raw data as it is. Because for a flow map, especially, you know, how it is right now, it's not going to give me the results that I want. So it's a better way to, let me illustrate this. So again, going back to the whole coordinate graph stuff. Right now, we are essentially, if I look at this, in a coordinate graph. Here is origin at 0, 0. And where we are and how we have the current flow maps authored is when we have a flow map at like a flat value, the origin point is here. So essentially it's 0.5. It's right here in the middle. If I were to have like my flow map be like this circle doing this, the problem is if I were to like invert this or use data that goes like in this direction or in this direction or in any of these other ones, I can't necessarily use them properly, because if I go here, which kind of means that like the direction should go backwards or in reverse, it's not going to work, because when I go from 0.5 to this direction, which is now 0, it's just going to stop. It's not going to give me the inversion that I'm looking for. So therein lies the problem. So how do I take this and get it to actually work? So what we need to do is we need to make it what's called signed. And signed essentially means that it goes into the negative, then into 0, and then into the positive. It gives the full range from -1 to 1. Right now, the range for this guy is 0 to 1. So we need to essentially take this guy and remap him to here at the origin. So how is that going to work? Well, how it's going to work is we're going to use a map node called a constant scale bias. It's going to rescale and bias the values. So if we were to look at this guy, like right now, I just have him at this kind of like off yellowish color. I have the standard flow map. What I need to do is I need to take him and plug him into that constant bias scale node. And this constant bias scale node is going to have two values, a bias and a scale. Bias is essentially a addition value, and scale is a multiplication value. So think of it almost like that in our mathematics. So if we want to look at this properly at the very least, so if we grab here and I say it's going to be x is going to be whatever value we have in the flow map, plus, and that's where the bias is, and then whatever the bias we set to be. So we'll say that's y, and that's in a little parentheses. Then the z that we have here, that's our scale. So if our value right here is 0.5, that's our starting off integer, plus something else, how do I get this to work? Well, we need to take 0.5 and get him to 0 somehow. So we need to end up with 0. So I need to give this guy a value that makes him 0. Well, the easiest one would be is -0.5. So in the parentheses, so 0.5 plus -0.5, of course, is going to be 0. And then what do I do now? Like I have this other integer, the z integer for the scale. What could I give to the 0? Because no matter what, he's going to be 0. How do I get it to actually like work, to like be proper values? So I need to make sure that, if I do 0 and this number to get it to work, how does I do it? The number that typically works is 2. So think about it like this. If this is going to be our origin at 0, how's it going to look if I do 1? So 1 plus -0.5. That's going to be still 0.5. Well, 0.5 times 2 equals 1. So that is how I know it's going to work, because now it's still here. This is still 1 and is going to remap back to 1. If I do -1 plus that, I get -1.5. So -1.5 times 2 is, let me do my quick little maths here. Sorry, it's been a little bit, so let me just pull up a calculator just to make sure that the math is mathing here. So we have -1.5 times 2. We have -3. So this guy's going to give me a -3 value. So maybe not exactly actually, sorry, I'm wrong. I started off with -1. It's supposed to be 0. So 0 plus -0.5. So that's -0.5. So -0.5 times 2 is -1. So the math is mathing. I was already basing it off of the -1 value. So remapping 0 gets me to -1. Remapping to 1 gives me 1. 0.5 gets here. So that's how I can remap to the full negative value. So knowing how to do all this basic math, that's exactly what I want. So let's go back here and do this constant scale bias. So let's do -0.5 and let's do 2. And if I want to look at the preview, hey, that looks kind of familiar. What does that look like to us? That looks like the difference value that we have for our flow map. So as you can plainly see, it's working, which is good. So from here, I could plug this guy in and he will actually distort this guy. So if I take a multiply plus this, texture coordinate node, and I plug this in, he is essentially working. But, actually probably I shouldn't do an add. I should do an add, not a multiply, sorry. Take this plus this and do this instead. Multiply was I was doing tiling. So this gives us the value that we want. So it actually gives us the distortion that we're going for. So if I take these two values, so I have this panner node and I have this guy. So if I do an add together for them, because this is still going to give me my texture coordinate node. So if I do this plus this, watch what happens. Hit save. And boom. Now we have the flow map. Now it looks like it's working, but remember, the flow map has not moved. It has not actually started its scale of distortion. It's just panning. So this gives us a bit of distortion to start off with. And, again, you could end it here. That could be it. But that's not what we want. So let's actually start to go in and create the flow map animation. And for the flow map animation, let's start off with taking this time and moving him outside of the panner. And we're going to take him and we're going to add a multiply. And we're going to add a new value. This value is going to be our time speed, because we can actually warp this time speed to be different. Now, he's not going to be, I'm not changing him for the panner, but I'm changing him for the flow map at least. So we're going to plug him into here. And now I could take this and I need to apply it to a new node that you probably have not used before. Because this node essentially is a mathematical formula, but it basically calculates a loop. So what happens is that whatever value you get in there, it takes the value. And again, time is a constant. So it's going to be going like 0, 1, 2, 3, 4, 5, 6, 7, 8. Like it's time. So it's going to keep going through. So this gives us motion. But now I need to take this and apply a loop to it to create the loopable animation, the start and finish. The node we want is a frac node. Frac, how it works is it goes to 0, then it goes to 1, and then after 1, it loops right back to 0. But it doesn't do a nice loop. It just kind of back to 0, and it's going to be a harsh change. So if I take this and I apply him with a multiply. So I'll do a multiply here to him. Let's hit save. And as you can see, he is animated, but you can see how he stops like that. He goes 0 to 1, does a full loop, and then loops back to the start. So essentially, we need to find a way to not have this issue. And one of the easiest ways you can do that is, here, let me quickly use a paint node again to illustrate this. So here's our animation at the start at 0. He's going to go straight like this up to 1, and then he's going to stop, go right back to 0, and then loop again, and then stop. We don't want that. So what I'm going to do is I'm going to add a second frac node, but I'm going to offset him change his starting point. Because right now his starting point is at 0. I'm going to start him at 0.5. So at 0.5, he's going to do the same linear adjustment back to 0.5. So he's going to 0 to 1, but his 1's still going to be here, and then back over here, and then stop. And then do the same thing again and stop. Then what I'm going to do next is I'm going to use a lerp node to mask out this part of the animation. So right now, if I grab from here to here to here to here to here, here and here, this gives me a loopable animation. It's going to constantly just get to 0.5 and loop back to 0.5, almost like it's creating a kind of arc. Like if I go back like this. So he's going to keep looping over and over and over again, no matter what, but he's never going to hit 0. So it's never going to be a hard like stop. So the animation is going to be a little bit smoother, which is going to be helpful. So let's start off with taking a frac node, because again, we need the frac node part. So let's go in here, do a frac like so. But again, I need to use an add node on him before I add him into the frac. So this is going to offset or move him just like how most other offsets work. So take him, plug him into this frac. And now what I'm going to do is I have to kind of make a duplicate version of this. So how it's going to work is I have now 2 textures. So I have the same texture and I have the same add, which is going to take the same pan. But now I'm going to take him, multiply him with this guy, and then plug him in like so. So now I have part 1 of the animation and part 2. I say part 1 and part 2 because this frac, you have to make sure you know whatever the frac that doesn't have the offset in it is, that's your first part of the animation. You cannot flip these 2 guys. They have to be always first one, second one. Because when I grab the lerp node and I plug him here into A slot and him into B slot, they need to know how that animation is going to work. So now, how do I get the animation to loop essentially? Well, that's actually fairly straightforward. We're going to take this frac and we're going to plug him in to something, but oh wait, I need to change it so the animation's a little off, because right now he goes 0 1 stops 0 1. So like that stop right there is going to break up the loop essentially. So I need to change it so that the loop doesn't create that weird stoppage. And what I can do is I could take this same constant scale bias with the same value, the 0.5 and 2, and that's going to loop my animation to be from 0 1 stop 0 1 stop. Like I can change it to be -1 0 to 1, then -1 0 to 1. So that's going to at least get me a 0 1 0 1 type of like animation in a sense. So grab him, does the offsetting that I want, but the problem is I can't use a negative. If I use a negative, because again, it's -0 1, flips back to -0 1. If I do negative, then it's going to invert it. It's going to invert the value, flip them in reverse. And I don't want that. So what I can do is I'll take an ABS or an absolute value, and it gives me the absolute value, which is always going to be the positive value of the number. So if I get a -1 as a result, then it's going to just flip it to be 1. So now it's going to be 1 0 1 1 0 1. Like it's going to be the same 1 0 1 parts without it being always a negative. So using this, plug him into the lerp, and now as you can see, he takes the animation and he's going to constantly softly lerp right back into the animation over and over and over again, which is good. So you can see here, panning, loopable animation no matter what, always over and over and over again. That's how you can get a flow map to work in here. Now, like I will say, you could stop right here and just be done with the flow map, but we're not done. So now you can take this actually. So we have the flow map right here and take him and just quickly swap him over, and you'll see how a vector map is going to look compared to a flow map. So it's going to create like a bunch of, again, random noise and stuff on top of. Now, we don't want that. So I'll take this, plug him right back into here. And how do I take him and bring them both together? Well, that's going to be very easy. I got to take this mask component, but now I need to add one more for him, and then now two for him. Because what these component masks are going to do is, instead of masking the R and G, it's going to now mask the R and the G separately. Same thing for him. Now it's going to be the R for this one and the G for this one. And now the reason why is because now I can do an add for each one of these guys and now add together these two values and then add the greens together. What this does is it takes up essentially what we're doing right here for the panner node with the add, where it's adding together the flow map and the panning part together. So I can use that to my advantage. Let me just scooch some of these guys around so I still know that this is the calculation for the flow map itself. So now I have the new combined vector map and flow map together, but now I need to add in append vector so that I can now pair the two together. Because again, this used to be an RNG going to this constant bias. Now I need to plug both of them together in here to give me the values that I want. So let's hit save. And now we have a new problem. We have the vector map and the flow map going at the same time, and the vector map is very strong. So what I probably need to do is I need to probably add a multiply to this guy right here. And this I'll call my vector map strength. That way the vector map is not going to be as strong as the flow map part. So let's hit save. So now you can see I have a little bit more warping and distortion going on here, but now I can still see my flow map happening, which is good. So now what I can also do is I'll take this guy right here and I'll add another multiply here and I'll call this my overall flow map strength. That way I can control the intensity of the flow map overall versus how it was before. So I'll do like 0.2 for this guy. So like if the flow map seems too strong for me for everything, so let's just do this. So now it's just like give me just a little bit of information. So let's do maybe 0.65. So done a little bit stronger. So, less is more in this approach. So now that we have both flow maps now working, I'll say it again, you could end it right here and be done with it. But again, we're not done yet. We need to now add a third type of vector movement, and that is using a distance field. Now you're probably wondering, what is a distance field and how does it work exactly? So how a distance field typically works is and I'll use this as the example. When I look at this, it's basically taking the intersection of this mesh and the plane and using to generate information. This information is in the signed format. So it's from -1, 0, and 1. So it gathers the intersection point, the inner and outer points as well. So it generates like a gradient inside and outside. And this distance field, whether it's the intersection or just the placement and position, is used for a lot of different things inside of Unreal Engine. Inside of Unreal 5, distance fields, no matter what, are generated by default because they use distance fields for things like lumen. Lumen is one part of it. You can even use distance fields to generate some simple shadows, to generate simple ambient occlusion. Unreal used it for Fortnite very early on to help generate some very cheap shadows and ambient occlusion when they were using Fortnite because you would have destructible environment assets, so they needed some cheap shadows that weren't baked onto the meshes. So you can actually use this to help generate some cheap ambient occlusion or just cheap shadows as well. Again, it's already default inside of Unreal Engine, so it's already there if you want to use it. So again, with that being said, we can use now the distance fields to generate this stuff. Now, a distance field gradient, how it's going to work is it's going to take, like if I grab this right here and just plug it in, how this is going to work is it's going to take a distance field, but how distance fields typically like work for this is, like essentially what, actually I need to change something too, because it's not going to work, because if I grab this as it is, nothing's happening. And that's because with distance fields, they're already kind of very relative to the mesh, but I need to change something out of this. I need to change the distance field gradient to a specific size. And to do that, I need to use a type of node called a normalize node. And what normalize does is it takes the values, whether they're super long or super short in some instances, and remaps them to the same size, 1. So if I take this, watch what happens to the distance field right here. You can see it's already changed in this, so watch what happens. When I move this guy around, he's going to have this distance field around him, and I move him, he changes the distortion gradient. And you can see there's this intersection right here. This is that one aspect that's always going to be around the mesh. Now, what I see right here that is something I don't like. It's subducting into the mesh, and I don't want that. I want it to feel like it's flowing outward from the mesh. So in order to get it to actually not do this, I need to take this value and I need to add a multiply to it, but I just need to change it to -1. What this will do is it will actually invert the gradient so that it goes outward instead of inward. Actually, I think I might have flipped it around the wrong way. I think it has to be this part here, this part in here, and this part here. So now it's going to flip it the other way around and then give me the 1 values. I feel like it's not actually giving me the information I want. He's actually subducting inside of him still. That's not good. So let me see what is going on, because it's supposed to be that you take this, plug them in, and then that should just automatically give you the opposite of it. Here, what happens if I swap these two around like that? I mean, they're moving around, they're just subducting right under here, and I don't want that. So let's see what's going on here. Okay, let me check something real quickly. Here, if I just probably take just the append vector of just the 2 values like this. Let's see what this looks like without the flow map on top of it. So they're moving and panning, and then they do the same subduction. So we got the -1 right here. If I grab him, what if I do a multiply, convert him to a parameter, call this one df for distance field, vector strength. And I'll set him to like 0.5. So yeah, so he is creating at least a vector around him. Some parts he's pushing off, some parts he's pulling, but he's still kind of wrapping around. So that might be exactly what I would want to use possibly. So let's try and go with that. But let's also take into account that this is just it being separated from something else. So let's combine the other aspects of this. These guys. Scooch these guys around. Also, another thing I wanted to note is that if this doesn't look right to you, like if it doesn't feel like it's looking exactly like what you're seeing right here, is because I have, again, distance fields are generated on every single mesh. They're almost like little proxies. So the generated info that you see here, I have it turned off on the plane and what's underneath it because distance field affects everything. So I have, if you go into any of these static meshes and you type in distance field, mine's already unchecked. If you check it, it's going to look like this, but I have mine unchecked. So that's why this looks different than yours probably by default. So uncheck the plane, but not the spheres or rocks or whatever else you're using that you want to influence on the mesh. So let's take into account this. So let's go back in here, grab the two mask values and do the same thing where I add the red to red and then the green to green. Combined these guys first. Then I combined them together here with these two. Because I want the flow map to be kind of on its own, the painted flow map. And then everything else can be just, you know, combined in the two different pattern ways like this. So hit save. Let's see what our result looks like. Yeah, so it looks like he is actually not like, here, let me show you the result that it looked like before. So just, yeah, oh, actually, no, it's more like not subducting, but he's like just wrapping around him and stuff. But, I mean, if I want to, I probably could just use the same masking component to start off with a area of non-influence, so it doesn't look like that. But we're going to hide all this stuff anyways on this subduction. So we're going to make like a little skirt around here, and that's with the other distance field part. So let's just flip them around the other way. So for now, let's go with this. And, you know, now we have 3 different forms of movement for our texture. Let me actually quickly swap out some textures because now I'm ready to see how this looks like with like lava. So let's go in here, change this to lava. Again, make sure I'm using the same texture. So we use lava. And we're going to plug him into the emissive color. Uncheck that. And let me change the base color to be something very dark, because that also influences the look of things. So if I hit save, yeah, we're working pretty good. So let's grab a multiply. I'm going to darken him by like 0.75. Add a contrast node. It's like 3. Let's see how we're working with. Yeah, we're getting there. Let's see. Let's do 2, maybe 0.9. There we go. Yeah, this looks pretty good. So what we're seeing right here is, you know, we have the emissive material started. And the reason why I have this kind of dark spots here and the light spots here is because lava has an effect called black body radiation, where the black areas of the lava look dark, but they are actually radiating a lot of heat. They essentially are just, there's a term for it in physics, but basically they're still hot and moving, but they're just very dark. You don't want lava to be always like this, even in this demo. So we'll go here, and I'm just going to apply 2 multiplies now because I need to take this guy one step further. And that is, one of them is going to be my color for my emissive. So this guy will be like orangish red, like that. And then this will be my emissive strength. So I'll set him to like 50. And now, boom, flowing hot lava, like so. But we're not done yet because we have the lava material, but now we need that last bit of masking. So we're going to use distance fields one last time to get this like little mask around things. So let's quickly go into our little distance field value. So we need to grab one more distance field, but not distance field underscore something. We need distance to nearest surface. And this is where we have that intersection of the distance field creating that intersection mask. We're going to use that with a divide because we're going to be pulling because it's using grayscale values. So we're going to apply a value of about, say, 50. Let me convert it to a parameter. Call this one my distance field edge mask strength. I know that's a mouthful. Plug that in. And then we're going to take a contrast node and set it to be at least like 1. I think that should be good. And then from here, this is our mask for our distance field. So we're going to use this with a lerp. And I'm going to grab a texture. Use my cooled lava. And how all this will actually work and show up in is the color that you're getting from here, the result of this actually is going to be not white, but black. Everything else is going to be white. So I want this to be in the white, and then whatever the mask is for this to be black. So the cool area is going to be where the mask is going to show up. The white area is actually going to be the flow map part. So as you can see, I have now cool lava showing up around here. I could probably even maybe mask him a bit further. Maybe do like 2. Like that. So now we have like a nice little island. And as I move, him around, like I said, he's going to generate a distance field. And I can even shape the distance field however I want. And it's going to mask out however we want him to be, essentially. So for the most part, this is how you would essentially take a lava shader. You probably would just change some things around if you want to turn this into a water shader, maybe. Like instead of hot lava, it would be water. So you probably would use the single layer water material system. You would even use like foam instead of like cold lava to do like foam trails and stuff. So for the most part, that's generally a lot of the same information with flow maps. So that's what's really good about this. We took a bunch of different concepts of like taking distance fields, taking vector maps, flow maps, and just general UV coordinate distortions and movements with a couple of different math values like frac and stuff, and constant bias scale to actually make ourselves a nice, movable, and dynamic material. Again, dynamic isn't just about the fact that it's a flowing, moving lava. It's the fact that when you plug this into the world, it can be changed based off of what you apply directly into it. Whether it's like a rock floating here or a shoreline or just anything else, it's going to look differently no matter what you apply to the surface of it. So that's what's really cool about this. It's a dynamic material. So that's flow maps, vector maps, and distance fields.